Hello everyone, welcome to live tutorial 1 on NS2 Network Simulator, brought to you by Illidan the Modeler from Northern Capital, Pandaria. I'll first make a quick overview on network simulators in general, on NS2, and a general workflow for network simulation, before I spend most of the time on a detailed example, which is the meat for this tutorial. At first, what is a network simulator? It's a simulation-based software environment to study the behavior of network and protocols. Some simulators also provide a development environment for users to create new models. There are several simulation methods used by the simulators, such as event-driven or discrete event simulation, flow fluid, time sampling, of which discrete event simulation may be the most popular one. There are several popular simulators in use, proprietary or free software like Omnet Modeler NS2, Omnet++. Here we only focus on NS2. A network simulator roughly consists of three main components: the simulation kernel, the model library, and the documentation. The simulation kernel carries out common routines, such as manipulating event lists in runtime, allocating memory, while the model library consists of the implementation of various network protocols. Since the network protocols may be very complex, their models are implemented in a compiled language for its runtime efficiency and its capability to construct complicated systems. The relationship between the simulation kernel and model library is analogous to that between a computer OS kernel and user applications. As we know, user applications implement their own specific functionalities using the services and API provided by the OS kernel. This is also true for the simulation kernel and the protocol models in a network simulator. The documentation is also very important. It tells the user how to use the simulator efficiently and how to develop new models. NS2 is a very typical discrete event simulator. Here I also roughly classify its components as simulation kernel, model library, and documentation. But in NS2, the simulation kernel and model library do not have a very clear boundary. And its documentation is only available on the web. Here we have a look of its source code tree. Under the directory of NS, we can see that there are a directory for the kernel, common, and then for many protocols there are separate directories to hold the source code, like TCP, Tora for MANET, or satellite, etc. I summarize the general workflow for network simulation as follows. Phase 1, implement the protocol models. Phase 2, set up simulation scenario. Phase 3, run the simulation. Phase 4, analyze simulation outputs. For any serious research, phase 1 is almost always necessary. For today's tutorial, we only use existing models, so we can omit phase 1 and starting from phase 2 until phase 4. Okay, the example is adapted from Part 4 of Mark Gray's tutorial, which can be seen on the following URL. We're going to have a look of its of its web page. And we can find this tutorial from the homepage of NS2 project. Here, Mark Green's tutorial. Well, this example is as simple as possible, but it covers a number of topics for using NS2. Okay, within this example, we're going to simulate such a network which only consists of two nodes. One node is sending packets to another node continuously. After the simulation, we'll find out how many packets the node receives and how large the traffic is. Okay, we'll first review the workflow. The first step is to set up simulation scenario and then run the simulation and then analyze the simulation outputs. We'll cover these topics sequentially. Okay, first set up simulation scenario. Here we have to use the Optical language. Optical language is a general purpose script language which supports object-oriented programming. It's an extension to the Optical language. After that, the NS will interpret the Optical file, passing parameters to relevant protocol models when it runs the simulation.